Hey there, everybody, and welcome to the Smash News Network. Welcome to the Daily Space Weather. Yesterday's video was all about filaments, and we talked about how there'd be an upcoming major solar uptick. All the chips are falling in place, folks, so you can expect this minor downtick in solar activity in the past 24 hours not to continue. Again, massive solar filaments are definitely the aesthetically pleasing portion of today's videos. That's the northeastern limb of the closest star. And we almost named that filament the one that's in the process of ejecting right now. We almost named it after Rush guitarist Alex Lifeson. The one ahead of it right up here, that's the Getty Lee filament. Let's take a look at some more views here. Here's the full disk view. These are 304 plus 193 angstroms ionized helium and ionized iron, respectively, from the SDO. You can see some activity kicking off right here. There was a coronal mass ejection. Is it earthly directed? We'll let you know. We'll bring you a cosmic ray report and lots more on today's video. So here is the northwestern limb. Great view there of the Getty Lee filament. It's the one that's shaped like a bass clef right here. And let's briefly show the southern hemisphere. We also do have two new sunspot groups despite mostly degradation since yesterday. There's the equatorial view, actually. And you might see a bright spot way on the left of your screen there. That is a new sunspot group. So we'll have two new named groups today and some unnamed groups as some sunspots have set and or evaporated. Let's see what's going on planet Earth. But first, let's take a look at sunspots briefly here before we show a little higher zoom level. There is the SDO continuum yesterday plus today. So there's one new group that formed right here. You can see that rapidly forming there right by my pointer. And there it goes. And this group down here just rose. So those are the two new sunspots. Here's your colorized magnetogram, also yesterday plus today. And we're going to talk earthquakes and volcanoes. But before we do that, please take a moment to press like, subscribe, share, etc. We don't think YouTube is recommending the content. However, we are recommending these products from Hemp Lucid. So if you are shopping at Hemp Lucid, try entering the promo code SMASHOMASH. It'll save you 10% on checkout. Promo code SMASHOMASH. It'll save you 10% on checkout. The most popular are the CBD tinctures, namely the water-soluble, fast-acting, a little shorter duration than the MCT suspension CBD tinctures. You've also got mushroom gummies, Delta 8s, body balms, and more, even CBDs for your pets. Again, enter the promo code SMASHOMASH on your orders from hemplucid.com to save 10%. Today's featured product on the Amazon shop is the GoWise 7-quart electric air fryer. Now, we have an air fryer that's a smaller model of this, and we will eventually upgrade to the larger model. Highly recommend you get an air fryer if you haven't gotten one. It will absolutely change the way you cook. Amazon.com/shop/smashomash. Links below this video to the Amazon shop. And last but not least, today's featured product, you can get that for 20% off on the Redbubble shop. So links below the description, links below the video in the description to the Redbubble shop. Save 20% by entering the promo code extravaganza. Today's featured product is Mansa, which stands for Make America Not Suck Again, as many of us have been demanding accountability for over 2 years for, shall we say, some bad decision-making at nearly all levels, as all institutions crumble, whether it's the family, education, medicine, business, finance. All institutions have crumbled in the past 3 years, and there is an obvious list of people whose fault this is. They should be held accountable. And that is just part of the process of making America not suck again. Yeah. And by the way, if you think these videos are political or that I'm political, guess again. I've never been associated with a political party and likely never will. My views are way too nuanced on all of the ridiculous talking points of, I'll say, the three, quote, major and, quote, parties in the U.S. In any case, it's up to you to make America not suck again. Do your part. Bureaucrats, not so much. Not doing such a fine job. What do you say? Let us know in the comments. Next, moving to volcanoes here. So, Ubinas in Peru has been erupting. And there's a great view from the Copernicus Sentinel Hub showing the volcanic ash emanating from the Peruvian volcano there just a couple of days ago. Anyway, here's the list of volcanoes that are currently erupting. You've got Mount Mayon in the Philippines, continuing to produce a volcanic ash plume. Now it's at about 10,000 feet of altitude. Fuego exploding in Guatemala, 15,000-foot ash plume there. It's a flight level 150. Flight level 210 over Nevado del Ruiz. Flight level 150 over Revenador in Ecuador. In Sabancaya. Sabancaya is also exploding. It's producing a 24,000-foot ash plume. Flight level 240. Flight level 230 over Ubinas. Whatever you do, don't pole vault the caldera. It could be unhelpful, and we need the views on YouTube. Next, global seismicity. There is the past 90-day situation. Current seismic activity level is low. Let's cite the quakes of a 5 magnitude or greater for the past 24 hours, starting with this 5.0 at the Solomon Islands. That was at 15:30 Universal Time yesterday afternoon. So quite calm here over the past 24 hours. There was a 5.0 early this morning at 0 dark 36 at the Kermadec Islands region. So it looks like only 3 5+ magnitude, 5 or larger magnitude quakes in the past 24 hours, the last being this 5.2 at Indonesia. That was at 10:12 Universal Time. We're coming at you a little bit later than normal today. And let's get back to space, since there is plenty to talk about. So the next thing we will show you is some more SDO imagery here. This is 211 plus 171 angstroms. You can see some coronal holes there in the southeast, especially a large coronal hole system down there. You can also see some activity popping off right here. That was a coronal mass ejection. Is it earthly directed? Well, we'll do some analysis a little later. Filaments over here, and don't forget this new sunspot. So this is the sort of there's a new sunspot formed here also. This sunspot right here is the latest one to rise on the eastern limb. And we'll briefly zoom in on that. So these are all 24-hour SDO videos from the Solar Dynamics Observatory. And these wavelengths are part of the extreme ultraviolet spectrum. The reason they must be viewed from space is because these wavelengths are not visible from the surface. The extreme ultraviolet portion of the electromagnetic spectrum is filtered out by the time it reaches the mesosphere. That is why these images are only available from space, although you can see many of the features from ground-based solar telescopes. Anyway, moving right along here, let's get to some more stats. The 10.7 centimeter radial flux now dipped all the way down to 155 solar flux units. Again, don't expect the decrease in solar activity to continue, as the sun is breaking out of its support levels. In fact, this 155 level is a support level. And it may drop a little bit lower here, but we are just getting to the meaty part of the North Pole current sheet. So more about that in a moment. First, a space weather enthusiast dashboard here, not forecasting any geomagnetic storms or geomagnetic unrest. So that's a 3-day forecast from NOAA. Let's briefly take a look at the Enlil spiral, the NOAA Enlil spiral. You can view that yourself on the Space Weather Enthusiasts dashboard if you like. It's part of the Space Weather Prediction Center. And let's check and see what NASA's been modeling. So here's the Integrated Space Weather Analysis version of the Enlil spiral. And NASA is expecting that CME to miss to the west. It could be a glancing blow, though, so it may brush past Earth's magnetosphere, causing some minor perturbations. It does not appear to be a direct hit, at least according to NASA's model. We'll show some more in-depth information on that later in the video. First Earth's magnetic moment from space. There are the past 4 hours of the space weather modeling framework. This depicts the likely model of magnetohydrodynamic pressure surrounding planet Earth to about 12 Earth diameters for the past 4 hours. It's the geospace magnetosphere movie magnetohydrodynamic pressure, the units of which are nanopascal. Next, the ground magnetic perturbations map. Geospace delta B refers to changes to Earth's B field, the field that goes through the magnet, this magnet being the Earth. And this depicts the last 4 hours of changes to Earth's B field, the units of which are nanotesla. It is a geomagnetically calm situation for the past 4 hours. And indeed, the past 24 plus hours, it's been geomagnetically calm, just a brief period of geomagnetic storm there, mainly caused by magnetic fields, not even a particle shower so much. Planetary K-index is a global geomagnetism average. The current situation is KP 2.33. Real-time solar wind here, quite unremarkable for the past 24 hours. Solar wind density here about 6.5 protons per cubic centimeter. Solar wind speed, solar wind density 6.5 protons per cubic centimeter. Solar wind speed just over 500 kilometers per second. GOES magnetometers here, fairly smooth for the past 24 hours. Seeing a tighter range here, lower highs and higher lows. Next, let's look at the heliospheric current sheet. And here we've got some action kicking off. The real place to watch is this north heliographic polar magnetism zone. It is still up there. We've got some indications it's not going to be very long. But in any case, that's our top view ecliptic plane field plot. Earth has recently, in the past day, moved into a North Pole-oriented current sheet depicted here in green, and we may see a huge strengthening of it, especially if we see this coronal hole suddenly lurch down toward the equator. If that happens, you never know how much solar activity can pop up, and suddenly, keep in mind the magnetic environment can change with basically no warning. Here is a line-of-sight field plot. And you can see some action happening there with the sun's B field right around the eastern limb. You can see that little extra bit of B field popping up there. That is the influence of that new sunspot that just rose in the southeast. So that's our line-of-sight field plot. It depicts the solar magnetogram in grayscale, solar B field in blue, north and south polar fields in green and red respectively. And there's a latest image. And here is our line-of-sight coronal hole plot. We are just getting that polar coronal hole moving into view here. If you bring up the last image right there, you can see that blob of green up there. We are waiting for that. And keep in mind, it can happen quite suddenly to lurch down toward the equator. So that is part of the solar cycle process. We've been documenting it for the entire solar cycle 25. And let's move on to some coronal hole views from SDO. So you can see this North Pole coronal hole here rotating in. This is also North Pole oriented. And you can, of course, see this CME happening over here. Also some plasma reorientation happening in this area. Let's move on to sunspots next. There's the sunspot situation. We've had a general degradation here, a reduction in sunspot number overall, I suspect, but at least 2 new groups likely to get names today. This one up here south of 3351, and then this one down here should be known as 3353 later today. Probably won't be named until sometime tomorrow, but hey, we like to be ahead of the curve here. Sometimes so far ahead of the curve that people think we're incorrect. It's cute. Anyway, here are sunspots from the zoomed-in SDO continuum. We've got 1600 angstroms on there also, but it's covered up by the SDO continuum. That was just a mistake on my part. It's only depicting the continuum because that layer is over the top of the 1600 angstroms. If you see that in the lower left corner, that's what that is. That is the past 24 hours. So again, we'll have a new sunspot group here, and it's pretty magnetically complex already. It's at least beta gamma class, perhaps even beta gamma delta class. We'll find out later. Besides that, most of these groups fairly stable. We still do have a high likelihood of a large flare up here in the northwest. Also a high likelihood of a large flare right here as this group rapidly forms. And it's time to talk energetic particles. And, well, really energetic particles, ones that are from outside the solar system is where we'll first start with the cosmic ray report. So here's your cosmic ray report. We're going to look at 7 different cosmic ray monitors. We show the same ones regularly on the channel to show people the evolution of the solar cycle. Keep in mind, cosmic ray flux is inversely proportional to solar activity. In other words, when you have a lot of sunspots, you have low cosmic ray flux. And when you have no sunspots, you tend to have high cosmic ray flux. I won't get into the physics of it at the moment, because this is the daily space weather after all. Cosmic ray flux at Apatity has dropped significantly over the past 30 days. So there you can see that drop at Apatity neutron monitor. And then Barentsburg neutron monitor also showing a major downtick for the past 30 days, an even more significant downtick than at Apatity. Big downtick in cosmic ray flux at the first 2 monitors. Let's check Athens, Greece next, going much farther south. And there, a big decrease in neutron detection there at Athens neutron monitor as well. So huge decreases in cosmic ray flux from the first 3 monitors. Mexico City's next. That was a teaser. Mexico City's next. A large downtick at Mexico City as well. So big decrease in cosmic ray flux over the past 30 days. And by the way, if you notice, there haven't been a lot of solar energetic particle events or even geomagnetic storms. Don't you find that interesting? Some of us find it interesting. More on that in a minute. And let's look at 3 more monitors here. We'll look at Oulu, Finland, as well as Antarctica. So there is Oulu. Big downtick at Oulu for the past 30 days in cosmic ray flux, as we just dropped below the lowest portion of cosmic ray flux for solar cycle 24. So we're just getting below that point now, and you can expect us to get significantly below that point because, well, this solar cycle is significantly stronger than solar cycle 24. So that's Oulu, a big downtick there. DOMB Antarctica, missing data, but of the 17 days we have, big downtick there. And same thing with DOMC Antarctica. So major decrease in cosmic ray flux. If you want to read more about cosmic rays and grand solar minimum and all this other stuff, check out our forum. Now this graph depicts proxy data because we can determine how many sunspots were likely to be there, because there is, again, an inversely proportional relationship between cosmic ray flux and sunspot number. We can use proxy data from tree rings to analyze the proportional relationship between carbon-14 to carbon-12. And basically the way it works is when there's more radioactive isotopes, that's the carbon-14, we expect to see a lower sunspot number. So we have a whole article about this on the forum at smashomash.com/forum. It's part of the Sun forum. It's literally the Sun is that forum. And we do have a couple articles listed here because this is just more evidence against a grand solar minimum, because we aren't seeing one. You have to have at least 2 weak solar cycles in a row to see a grand solar minimum. We just aren't seeing that. So we've got some articles posted here. You can find more articles as well about the Sun in that section. And there's a whole cosmology thread too. So smashomash.com/forum. If you want to read about smashomash.com's mission, that's available on the forum as well. smashomash.com/forum/mission. You know, we built our website back in 2019 in response to pathetic censorship from social media organizations. Maybe we should thank Facebook, but they suck at their own job, so I guess we won't do that. Next, moving to energetic particles. The GOES proton flux here, and these are a different type of energetic particles. Cosmic rays typically are coming from out of the solar system. So the GOES proton flux these are solar energetic particles, and these are lower energy than cosmic rays. These particles typically end up getting stuck in Earth's magnetic field lines at the poles. No spikes in the GOES proton flux, and pretty low solar activity here. So interestingly enough, once again, a solar flare happening while we produce the video. This is becoming a pattern on the channel. Shout out to the sun for dropping a signal as we produce the videos. Dear sun, if you're conscious, I'd like to become a billionaire soon. Thank you. I will start doing some very different content production if I mysteriously become a billionaire overnight. So there is the GOES X-ray flux, and let's take a look at some of our favorite wavelengths. Here we'll add 94 angstroms to the SDO continuum to show those active regions. And let's see, the most active region, it looks like the most activity indeed came from up here in the northwest, which is what I forecasted yesterday. So this is just a basic understanding of the correlations, and this isn't really any sort of advanced heliophysics stuff. This is sort of these are widely accepted facts, and it's well documented in the scientific literature. Here's the full disk view. That is 131 plus 94 angstroms from SDO. So again, we still do have quite a high likelihood of large solar flares. We're delighted to see one happening once again while we produce the video. It is just a regular thing on the channel. And cheers. Yeah, nature. It's pretty interesting. And if you've got comments to leave directly for the closest star, make sure you leave them in our comments. Many of our viewers are convinced that the sun watches our videos. We're going to go to coronal mass ejections here to do some more in-depth analysis of that. But first, let's see what's going on overhead. This is what's above us in Lehigh Valley right now. I like to use the star chart from, what the heck? Oh, there we go. It's good. There's a star chart from skyandtelescope.org. Mercury getting very close to the sun here, at least from the perspective of Earth. Saturn is up there as well. And once again, if you are viewing the evening sky, you get a great view of, let me go back 1 hour here, you get a great view of Mars, Venus, and the moon, just north of the ecliptic, which is the path the sun takes across the sky, that aqua-colored line there. Great view of the third and fourth brightest objects, depending on how bright Jupiter is. Mars is sometimes the fourth brightest object in the entire sky. Here's your solar system forecast. Yeah, is where things are today. That's where things will be in a week as we approach the July full moon. It will be, oh, it looks like a July 4th full moon. How about that? Full moon on July 4th, Independence Day, and we hope you are independent of waste, fraud, and abuse. I'll just say waste, fraud, and abuse. Yeah, there's a lot of that going around. Did you know that we're also on Instagram? If you want to see lots of fitness and lifestyle posts, make sure you join us over there. And if you want to share anything with us, that's a good place to send us a direct message. If you haven't seen our shorts, if you've got people with short attention spans, send them our shorts. It's youtube.com/smashomash/shorts. Lots of 15-second and slightly longer videos in there, so check those out. Little tidbits from these videos, and some are not even clips from these videos. Thanks to all of our new YouTube subscribers, etc. Don't forget to press like, subscribe, share, comment, and let's move on to coronal mass ejections. So here are yesterday's frames. And we show this because it shows computer interpolation on the left. So that is a computerized analysis to try to look for halo ejections, which are the kind of coronal mass ejection where you get a halo In other words, if you see plasma coming out like this, it's an indication that it's headed directly toward the aperture, unless it's on the opposite side of the sun. So we've got this CME coming out of the east. We've got this one coming out of the west. That may have a small Earth-directed component. This one out of the southeast does not appear to have any Earth-directed component. There's that one coming out of the west. We'll let that play through one more time and then show today's frames. That is 106 frames from yesterday, June 25th. Here are an additional 38 frames from today, and you can see that Alex Lifeson filament there blasting off into the north. Just like we said yesterday, filaments were the story of the day. So here are the SOHO coronagraphs, LASCO C2 and C3. And we'll also show stereo A. So that we just show this diagram so people are aware of the locations of these objects. It also depicts the solar orbiter, Bepi-Colombo, Parker Solar Probe, Venus, and Mars. So let's press play on these. Keep in mind these are not synced. They are different time frames. Time and damp states, not damp states. Time and date stamps are shown at the bottom of the coronagraphs there. So there's that one out of the south. It's like the south-southeast. I don't think that one has an earthly directed component. Very unlikely. And the one that comes out of the west may have a minor glancing blow component. I don't suspect it'll be very much. You might see a KP4 or 5 from that. And before we get to filaments, let's look at our custom coronagraph. So here's a 24-hour coronagraph. As we typically do, you've got the SDO 193 angstroms, which is great at showing the extended corona. By the way, don't be surprised to see a CME today over here from the east. So you see this huge plume of plasma out here. There's a little bit of an outflow on that. That could turn into a massive CME basically with no warning. There is a sunspot just ahead of that huge filament. Again, these are 24-hour videos. And you can see that CME comes from this area right here. A coronal hole briefly opens up there and then closes back up again. That would be a South Pole-oriented coronal hole. It is on the opposite side of the sector boundary crossing. In other words, this is North Pole magnetism on this side, at least in the corona, and this is South Pole magnetism on this side. Sector boundary crossing is like something like this. Anyway, here's just 193 angstroms by itself. Another 24-hour SDO video. And we are delighted to show it to you. We would prefer to keep doing so. Next, we're going to get to filaments. So we started out talking about filaments, and now we're back looking at the ground-based solar observatory from El Teide, Spain. And there you can see the Alex Lifeson filament. I forgot to name it on Twitter. I was wishy-washy about it, so I never really got around to naming it. But this one here is officially named the Geddy Lee filament. And there are some prominences over here as well. Make sure you follow us over on Twitter. You'll see all kinds of, if you're on social media, period, follow us on Twitter. If you've unplugged entirely, we don't blame you because it's truly pathetic and putrid in these monopolies. And by monopolies, I mean mainly, like Apple's not really a monopoly because iTunes, well, iTunes is crap, but Apple's not really a monopoly. But certain other big tech organizations like Google, Meta, and Twitter are absolutely monopolies. So all of the things that they're fixing that aren't broken, and all the things that they aren't fixing that are broken, and all the things that they are breaking that were working fine is truly pathetic. So again, we don't blame you if you're completely unplugged from social media because it is truly putrid in the current state of affairs. Of course, the last 3 years have been the most disgusting ever. But since about 2015, there has been rampant fraud, waste, and abuse, and a complete lack of accountability to justice systems, fraud, corporatism, etc. Tell us all about it with your tweets at Smashomash. Anyway, here are the past 2.5 hours or so, and you can see that CME slowly making its way away there from the North Polar Crown region. That is a massive crown prominence, you'd call it. And these are much more common at solar maximum, which means you can expect these to continue for the better part of a year. You can expect solar activity to continue around this level for the better part of a year. Why is that, folks? Can anybody tell us in the comments? I'll wait. Just let us know. Why is it that you can expect activity of this scale to continue for the better part of a year? Leave us a comment and let us know what you think. The answer is because we aren't at solar maximum. That's why. It seems very simple. However, a lot of people who can't get out of their own way, who've painted themselves into a corner, who don't understand physics, etc., who don't believe in reading any scientific literature, just spouting nonsense to their viewers and making millions doing it, think we've been at solar maximum since January. What do you think? Let us know in the comments. And let's move to bonus features here. We don't want the video to be too lengthy here. I don't want to spend too much time babbling about how ridiculous the world of space weather is on YouTube. Here's our first bonus feature, satellite charging hazards. There are minor surface charging hazards there in the Eastern Pacific. Goes electron flux here. Dipping down as I sort of forecasted yesterday. I mean, it's flirting with alert levels once again. We're expecting this to be decreasing as time goes on. That's the past 3 days of radiographic measurements by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. There is the 1-year graph of the relativistic electron flux. And there is the forecast model. I think I was right here yesterday. Didn't I say we'd be a little bit lower than NOAA's model? Anyway, that's NOAA's forecast for the electron flux. We'll also show the vibrational frequency of the F layer, which just happens to be the layer of the atmosphere where that electron flux is measured. Feel free to pause the video on this frame if you're not familiar with distances in kilometers and so on. Here's the vibrational frequency of the F layer, the bridge between Earth and space. It's at about 300 kilometers of altitude, and can I zoom in one spot? I'll leave it at 175, I guess. So there is the vibrational frequency of the ionosphere. Things are pretty normal here. No major signals are jumping out at me. We show it daily on the channel because you never know when archiving pieces of data will become useful at later times. So that's the current situation. We'll let that play through till the current moment and then show the anomalygram. Because frankly, that is hard for me to understand also, even having looked at it for years. Here's the anomalygram depicting anomaly in megahertz from a 30-day median. So some significant low-frequency anomalies happening there in places like Africa, the equatorial Atlantic Ocean, Central America, Northern South America, the Central Pacific. Low-frequency anomalies highlighted in red, high-frequency anomalies highlighted in blue. It's literally the rate at which the material is shaking. It's a vibrational frequency. Megahertz are millions of vibrations per second. So that's what's shaken in the F layer. Here's the latest image. That's 12 o'clock universal time. And there's 12 noon universal time anomalygram. Total electron content we show as well. It'll show the most likely places for GPS errors, but more importantly, it may show pre-earthquake signals. Who knows? It's possible. And we may actually have one today. We'll get to it here in a moment. Feel free to pause the video on this frame if you're not familiar with distances in miles. Here's the total electron content for the planet view. We do have some significant nighttime anomalies happening there. So major nighttime anomalies over places like East Asia. and also down here in the Southern Ocean and Antarctica. We'll make sure we let that play through one more time before we show the North American view, which may be showing us a signal here, forecasting an earthquake for Central America. So let's let that play through one more time. You can see those anomalies around the Southern Ocean and Antarctica, as well as nighttime major GPS errors around the equatorial portion of the planet. And since we can't analyze every area because it would take really long, and this channel does not specialize in forecasting earthquakes or claiming that we do, we like facts. But check out this area right here. There is a total electron content anomaly right in that area. So right in here, right there, you can see that anomaly in Central America. Is that a pre-earthquake signal? Is an earthquake about to happen someplace around Panama? Let us know in the comments what you think. Keep in mind, we don't think the space weather is causing the signal. We think the signal comes from the Earth side, but it appears in the space weather data. Let us know what you think. If that is an earthquake forecast, is there a 6+ magnitude quake coming to Central America within the next 4 days? That's basically what it is. It's a 96-hour window that pre-earthquake signal may be an actual pre-earthquake signal. Who knows? And let's close out the space weather section of the video with the latest intensitygram and the latest magnetogram. So here's this new sunspot that just rose. It's looking pretty weak. It's only alpha class at the moment. I only see one umbra there. There could be more hiding behind it or around its area. We do see a little bit of plasma filamentary stuff hanging out there. Also, this new sunspot is looking promising for producing large flares and so on. So check this out. There's that new complex group. It's this one right here. And it is indeed beta gamma delta class. So quite a lot of magnetic shear here from umbra to umbra. So that's another hot spot for the possibility of producing large solar flares. We're delighted to inform you of that. Anyway, there's the full disk rock back, and let's move on to meteorology. Now we're looking at sea surface temperature anomaly and currents. Did you know that when Earth goes into a prolonged ice age, what happens is cold water from Greenland melts, inserts itself into the North Atlantic, shutting down the North Atlantic Oscillation, which causes Iceland, Ireland, Western Europe, Asia, and eventually North America to freeze. Yeah, the North. It's very strange. You know, Earth's northern hemisphere climate is almost like a separate planet than the southern hemisphere climate. They've been known to do very, very different things at the same time in history. So we know from the geologic record that the AMOC, the Atlantic Meridional Overturning Circulation, shuts down. And that is what causes the albedo effect to go run away. Yeah, there's a tipping point for the albedo effect. If you get too much snow and ice here, and here, and here, and here, and here, too much radiation is reflected back into space, and Earth plunges into the most common situation that it's been in for the past 30 million years, which is snowball Earth scenario. It's not good for civilization, as Earth's human population contracts. The salmon population goes up, and the human population goes down, because it's very hard to grow food in ice. Anyway, that's the sea surface temperature anomaly map. And as you can see here, it is not shutting down. If you are banking on a year without a summer, that's some bad banking. Get a new banker, because you've been given terrible investment advice. Look at how warm the ocean is here around the UK and the North Sea and so on. Are you kidding me? That is not an ice age about to go into effect. Here's the Pacific Ocean. Again, the animation here is depicting ocean currents, and the colored gradation is sea surface temperature anomaly. Here's the Southern Ocean. Let's don't forget the Atlantic. I'm a big fan of the Atlantic, by the way. There is the Atlantic. I'm fanatical about the Atlantic Ocean. Look at the strong currents here off of the west coast of Africa. And we've also got the Indian Ocean for you. There are the sea surface temperature anomalies and currents in the Indian Ocean, and there is the Arctic. Anyway, let's blast through our... Man, look at all the cold water around Australia there as winter has recently arrived. And here is the surface wind scenario for the eastern world. So that's the surface wind scenario. Here's the jet stream scenario. We've got the jet stream blowing backwards here over the northern Indian Ocean, the Bay of Bengal. Here are the jet streams of the central world. Jet stream blowing backwards over southern Saudi Arabia and northern Africa as well. Here are the surface winds for this side of the planet. Yes, the jet stream usually blows from west to east, not vice versa. And here are the surface winds of the west. And here are the jet streams. Much more coherent jet stream over the U.S. at the moment, and it looks like some clear skies likely over Texas, as we've got a high pressure zone, evidenced by the strong clockwise rotation over the Lone Star State. As they say in Germany, everything is bigger in Deutschland, und everything is bigger in Texas as well, yeah? Here's our satellite map, and indeed you can see there are like no clouds over Texas. Let me press refresh here to let this thing spool back up. It's some pretty sweet imagery there from windy.com. You can download the free mobile app if you like. We're not paid to tell you that. That is just another customer service message brought to you at massive personal risk and expense by Smash Staff and I. In the Northeast, the weather is being controlled by a low pressure system here over Detroit. So you can see this strong counterclockwise rotation right over the Great Lakes. That is controlling our weather, and it's getting kind of rainy. Let's take a look at clouds and fog for this side of the planet. So that's what's going on. Those tropical systems there in the equatorial Atlantic fizzling out exactly as we forecasted about a week ago. That's called understanding atmospheric physics and knowing how to forecast the weather instead of fear-mongering, nonsensical noobing, relying on models and having no idea what you're talking about. If you're showing a 3-week forecast on your YouTube channel, delete your YouTube channel. You have no idea what you are talking about. 3-week forecasts are about as accurate as predictions of a grand solar minimum. What a joke. It's pretty pathetic. Here's the key for the weather.gov map. And lots of excessive heat warnings, red flag warnings, etc. If your location is lit, click your location. We've got some flood watches in the Lehigh Valley, PA. Right about there is where we're located, by the way. And here come some forecasts. So here is your Canadian smoke forecast. Lots of smoke here making its way down through Milwaukee and Chicago. You're going to have some major air quality alerts there coming as those fires rage on in Quebec. So that's your smoke forecast. We'll let that play all the way through. Just give it a minute. Plenty of Canadian smoke headed your way. If you want to smell like a campfire, it'll be good around the Great Lakes region. Anyway, here's your GFS 72-hour pressure and precipitation forecast as heavy rains strike the Northeast. And more coming. We've been having concentrated thunderstorms here for the past about 12 hours. Here is our total accumulated precipitation forecast, and we're showing this because of the flood watches. Portions of northern Pennsylvania, they're expecting to see about 3 inches of rain. Also, northern Minnesota expecting some heavy flooding. More like 4 inches of rain up there. Again, it's a 72-hour GFS pressure, GFS 72-hour total accumulated precipitation forecast in inches. And since we've got some heat warnings around the Lone Star State and so on, how about temperature anomaly forecast based on the same GFS 72-hour model? Keep in mind, temperature anomalies are shown here in degrees Celsius. It's going to be hot in also Oklahoma, Kansas, Missouri, Arkansas, Louisiana, also New Mexico, and parts of Colorado will be anomalously hot. Continuing right along to show lightning. Lots of lightning east of the Mississippi. Quite a bit in the Pacific Northwest as well. So that's your last 10 hours of lightning. Here are the last, this is the last hour of lightning strikes. Quite a bit of lightning activity here at the moment, and we've got some significant storms here around the Louisiana-Arkansas border. Hey, Shreveport. Yowzers. Some pretty active lightning cells there in northern Louisiana. Here's the full map view. And by the way, if you enjoy the content, visit our links. One of the ways you can help us out is by clicking on our links. You can find all kinds of additional content by doing so. There's even a permanent invite link to the Discord chat right there on the homepage at smashomash.com. And welcome to the Video Renaissance. Again, congratulations on realizing the channel exists. If you want to support the content, we are on Patreon. We do have a PayPal. However, the best way to do it would be with a Smash Team membership. The best value is the gold annual paid-up subscription. It's almost like getting 4 months for free because it includes complimentary merch. The gold level's $9.99 a month otherwise. The silver level's $2.99 a month, and the bronze level will cost you $0 per month. We do send out email alerts alerting our viewers about videos just like this one because they don't trust notifications from certain video hosting sites. Smashomash.com/SmashTeam if you want to support the channel via subscription services. That's the way to do it. The official subscription services site of the Smash News Network, least busted name in news. We're going to close out this video with your space and Earth weather combined with the U.S. Doppler radar map. There is the full 50-state view. Here's the lower 48 view. And we'll briefly show these strong storms here in Arkansas and Louisiana. They are moving south-southeast, actually. And that is actually part of that anticyclone system. Upper-level winds here are pushing that. So that would have a tendency to move more to the east. It's moving south mostly because of that anticyclone over Texas, a high-pressure zone, radiating winds outward at the upper level. Here is clouds and fog, and you can actually see a little bit of that clockwise rotation there centered on Texas. Clear skies over most of Texas, and here is your water vapor map where it'll become even more obvious. That large anticyclone there. And just so you know, anticyclones are high pressure zones. They are similar to Jupiter's Great Red Spot and nothing like a sunspot. Well, actually, they're more like a sunspot than a hurricane is, but it's still, it is a pressure exerted on the atmosphere, that dry air. In other words, a clear day. Get this, folks. You ever notice how the barometric pressure is higher on a clear day than on a rainy day? That's because atmospheric nitrogen is simply more massive than atmospheric water vapor, which makes the air heavier. Heavier, more massive, both in terms of being on Earth. Anyway, here's your recap. U.S. Doppler radar. Clouds and fog, and you can see that low pressure there rotating right around Detroit. And here is the water vapor map. And here is me closing out the video and heading back to the bunker because I am spooked by all this stuff going on in space. I'm spooked and scared because people on YouTube told me to get a bunker. So who cares about the science? I mean, if somebody sounds confident and tells you utter nonsense, they must be telling the truth, folks. They're not grifting. It's perfectly legit. So anyway, again, I'm back to the bunker. We'll see you soon, hopefully, assuming that the world doesn't end. And in the meantime, may that solar wind be at your back, and I am going back. Bye. Whoa.